Good evening, everyone. Welcome. Thank you for being here for the talk, Building Virtues Beyond Skills, Mathematics for Human Flourishing by Dr. Francis Su. Before I say hi to him, let me briefly introduce myself as well. My name is Oğuz Köklü. I am an assistant professor of mathematics education at Boğaziçi University. Today's speaker is Dr. Francis Su. He has, as you may expect, quite a long list of successes, awards, intellectual products. One of them is his book, Mathematics for Human Flourishing. He is currently a mathematics professor at Harvard College, and he has been the president of Mathematical Association of America. In addition to many others, he is also the writer of the book Mathematics for Human Flourishing. Luckily, this book is translated into Turkish as well, with the name için, Matematik. It's published by TÜBİTAK, and I already completed reading the book, and thanks for writing such a nice book on mathematics and how math is helping, is instrumental in reaching humans' virtues. We will hear more about the book and your thoughts about how math is, instrumental in reaching those virtues. So the floor is yours, Dr. Francis Su.
Welcome. Thank you so much for spending your evening with me. I'd like to have us think a little bit about how mathematics, think about mathematics in a different way than you might be used to. And I might point you to start by having a look at this picture, which is a piece of artwork that one of my students did in a mathematics class. And I invite you to just take a moment to notice it and reflect on this piece of art. What does it signify to you? What does it mean? And of course, if you take a look at it, you'll see that there's a themes here, a contrast between one side where the child is on a swing and the other side where it looks like someone has fallen off the swing. There's the contrast between the warmth on the left and the cold night on the right. And one of the maybe surprising things about this piece of art is that it was produced in a mathematics course, which I have my students reflect on the history of mathematics, the philosophy of mathematics, and also mathematics education. And what he was trying to depict in this picture is the question, why do some people flourish in mathematics and why do others fall off the swing? And that's part of the thing I want us to think a little bit about today as we talk about building virtues, not just skills. And I'll explain what I mean by that. But I'll begin with this story. This is my son, who is he's now about 4 years old, but this picture was when he was about 2 and he was just learning to speak. And because we live in Los Angeles, one of his first words was a helicopter. Although because we have helicopters flying over all the time, and one of the things that, of course, he didn't say the word helicopter. He used the word da da da. Okay, so every time he would hear a helicopter, he'd point up at the sky and he'd go da da da da da da. And he was born during the pandemic, and so the whole first year of his life, we didn't take him out anywhere. And then one day I took him to a hardware store when things started opening up, and we were inside the store, and he goes da da da. And I was thinking, wait a minute, there's no helicopter in here. But of course there was. It was a ceiling fan.
Yeah.
And so this actually highlighted for me that something that every kid does, right? They're able to look at two different things and think of them as the same thing, right? To him, the spinning blades of the helicopter were like the ceiling fan, and he called them da da da. And this is actually a virtue. This is a mathematical virtue that my kid and many kids, every kid uh, uh, e- e- exhibits at a very young age. We call it abstraction, right? The ability to say that two different things are actually the same thing, right? Somehow every kid is able to look at many different types of dog and figure out what makes them a dog, even if one is a tiny poodle and one's a big Great Dane, right? So that's the human virtue of abstraction. And one of the things that we do in math education is cultivate this virtue, right? We take it up to the next level. So that, for instance, if you are a mathematical thinker and you're working for a company like Netflix, and you might be interested in figuring out how to recommend the very next movie to watch based on what people have said that they liked, you might begin to think about this as a mathematical problem using abstraction, right? The idea that you have a person who has rated lots of other movies, 100 other movies in the past. You might look at their ratings as a collection of 100 numbers. And for a mathematician, that's a point in 100 dimensions, right? So somehow, make thinking about this recommendation problem for Netflix might be hard, but if you think about a point in many dimensions, that might be an easier way to think about this question, and actually begin to answer the question how I might recommend a movie based on the information that I have. You have lots of other people have rated similar movies, and each of those people is a cloud of points in some high dimensional space, and you're just interested in measuring some kind of distance. And so this is a geometry problem. And so the power of abstraction, the power to be able to say two different things are really the same thing, means that you can solve one problem by thinking about the other problem, in which the answers may be clearer. So abstraction is a virtue. It's a human virtue. It's something we're all born with, but we learn through education to take it to the next level. And so let me say what I mean by virtue. So I think about virtue as a certain excellence of character that leads to an excellence of conduct. So there is a being part and there's a doing part. So the being part is thinking about the part in which your character, your attitudes are shaped, right? And then it leads to actions. And now when people think about virtue, you often think about moral virtue, right? The idea that to have virtue is to be honest or ethical or truthful. But I want to enlarge the way we think about virtue by having us think about other kinds of character qualities, and in particular ones that could be shaped by a great mathematics education. So, for instance, if I am persistent in problem solving, that's a virtue, right? That's an attitude that I have so that whenever I encounter a new problem, I'm not afraid to sit with it a while and persist in trying to solve it. That's a character quality, but it leads to good actions. And so in the math education community, sometimes we call these things habits of mind, but you might think of them as dispositions. But I like to think about it in terms of how mathematics shapes our attitudes and our character. And so this is thinking about mathematics education not as a transaction, but as transformation, right? So the transactional view of education is I'm doing this studying this subject, studying mathematics to get a good job or to get into a good university. And in opposition to that, I'm suggesting we think about education as transformation, how education shapes our character, how it shapes our attitudes and our habits of mind. I like this quote by Martin Luther King, who said that it's the intelligence plus character. That is the goal of a true education, right? So it's not just intelligence that matters, but both intelligence and character is what we hope to uh, cultivate in our students. Some of my thinking around this was shaped by a correspondence with a inmate, incarcerated man in a federal prison, who wrote me out of the blue, interested in furthering his mathematics education. And this is a fellow who was involved in a series of armed robberies while he was as a teenager, and he landed in prison with a 32-year sentence for his crimes. And while in prison, he discovered a love for mathematics. And I'm a believer that mathematics has something to offer everyone, but I have to say, even I was challenged by um, his inspiring example of someone who I guess, we don't often think of as necessarily being interested in mathematics, right? So
Mhm.
part of the question I want us to wrestle with is who we see as as mathematical and who we don't. And I claim everybody, all of us as human beings, by virtue of us being human, are mathematical. And the way that we can think about that is through thinking about virtues. And Chris's story is actually one of the key stories in my book in highlighting the example, the power of mathematics to change lives. Here's
And
another example.
you have
Oh yeah,
pieces
go
of
ahead.
letters from from each chapter, right? With Chris, you have pieces of letters and email, maybe
Yes.
exchanges.
Yes. So Chris has a byline on the book, and because he contributed many letters from our correspondence that help, I think, highlight and emphasize many of the things that I'm saying around mathematics being very human and enabling us to live better lives.
I wonder, do you know or remember how he first started to think about studying math in jail? I mean, the first time or the first instance that led him to start working or studying math?
Yeah, I think what happened was when he got to prison, he started reading books, all sorts of books,
Ah, okay.
mathematics, philosophy, and other things,
Mhm.
and then he started developing a passion and interest in um, in pursuing the logical nature of mathematics.
Mhm.
And so, yeah, so I mean, he's a wonderful example of someone who, has built has shaped his character.
Mhm.
Mathematics has shaped his character, in many, important ways. Here's another, example that I like to highlight. So, one of my students, came back from an interview for a high-paying job on Wall Street. She's a mathematics major, and she went on this interview, and they asked her this question: how many times is a toilet flushed in New York City during a commercial break of the Super Bowl, which is a big football game in the United States? And of course, it's a funny question to think about because this company was a finance company, and they're not really interested in the plumbing in New York City, are they? Uh, and and if you reflect a little bit about why they would be asking her this question, you begin to realize that they're asking her this question because they want to see how she thinks, right? They didn't ask her to recite the quadratic formula. They didn't ask her of many things you might traditionally associate with mathematical knowledge, right? Like knowing certain facts or certain procedures. They were interested in virtue. They were interested in knowing how she thinks. Is she able to reason through this problem? Is she able to break a problem into multiple smaller pieces to solve? That's a mathematical virtue. Is she able to be resourceful in thinking about sources of data that might help her determine, for instance, the number of times a toilet is flushed? I mean, the number of people in New York City, right? You might start with that part of the problem. Or you might start with another piece of the problem, which is the number of times somebody needs to go to the bathroom in a 3-hour period, right? So there's lots of different ways to think about this problem. They were interested in seeing how she thinks. And so I claim they were interested in virtue. So what I'm distinguishing is the difference between skills and virtues. So, skills are things that are bits of knowledge, knowing how to do certain mathematical procedures, like recalling your number facts, knowing how to factor, taking a derivative, right? These are all things that people traditionally associate with mathematics. Whereas all the things here on the right, virtues, are things that are built by great math education as well. So being persistent, being creative, having certain habits to interpret, to define a problem, to be able to quantify certain things, to think abstractly, to be able to visualize, right? All these things are ways of being, habits of mind, character qualities that lead to the good actions, which is, hopefully being able to address or solve the problems we're trying to think about. Having courage to tackle problems you've never seen before, right? Those are virtues. And so all the stuff here on the left, the skills, these are the things that we often associate with mathematics. And the part of the problem here is that most people, because they think math is just the skills, they ask the question, why do I need to know this stuff? And that's a valid question because a lot of the stuff that you learn in a math education, especially, in high school or so, you might never use, right? For instance, if you learn trigonometry or calculus, I'm not saying these are not important. They are if you go into science or engineering, but they're not used on a daily basis if you don't end up in a scientific field. And so students rightfully ask, why do I need to know this stuff?
Mhm.
And also, these things on the left are replaceable, right? So if you think about the AI revolution, which we're now living through, all the things on the left are things that computers or artificial intelligence can do, and often more efficiently, right? So I like to tell my students, if your job depends on skills, your job is in jeopardy, right? In the coming revolution, we're less interested in skills than we are in virtues. Virtues are the things on the right, right? So all the things on the right, I claim, are actually things, if you want to be practical, these are the things employers actually want, right? Like they want people who are able to be creative. They want people who are able to define, to quantify, to generalize, to visualize. And these are the things that actually, as human beings, we do, and that in many ways will separate us from computers, right? And so, if you want to be practical, and I don't necessarily just want to be practical, but even if you want to just be practical, employers actually care about virtues. Okay, so what I'm saying is, don't get me wrong, skills are important. But I claim that virtues are just as, if not more, important than skills. And this is the heart of what it means, in fact, to be human. So if you think about the stuff on the right, the virtues, these are the things that make your life richer. These are the things that you're going to carry with you no matter what profession you end up in. So if you're a mathematics student, uh, one of the things you take out of a great math education is having the ability to take a problem and strategize about it, right? Having the ability to be creative, to having courage to tackle problems you've never seen before. These are the things that you carry with you the rest of your life, whether or not you're in a mathematical career. So, virtues make your life richer. And in fact, many of the things that I'm talking about that I care about deeply are also the affective virtues, the virtues that relate to your emotional engagement, right? Having an affection for learning is built by a great mathematics education. Having the expectation that when you encounter a new idea that you're going to be enchanted, having a certain hopefulness that's built by a great math education, the hope that hard problems can be solved, right? Maybe that hard problems can't always be solved, but a great math education will teach you that many hard problems you can at least make some progress on and are worth thinking about. Having a disposition to beauty, right? These are all built by a great math education. So these virtues make your life richer. And it's another way of saying that these virtues lead to human flourishing, the ability to live life well, even in difficult circumstances. So I'm just going to talk about a couple of different, a few virtues that I think are built by great math education, and then we can, maybe have a discussion. I'll talk about some virtues. I'll talk about some ways that I've tried to think about my own teaching of mathematics, and then we'll have some Q&A. So here's one: having a disposition to notice beautiful things. Right. So I think mathematical beauty is noticing unseen details. It's marveling at unseen possibilities. It's understanding the patterns of the world that you might not first notice. And it's treasuring many of the connections that are built by a great mathematics education. So, for instance, you're walking through the supermarket, as I did once in the United Kingdom, and came across this fractal looking cauliflower. Right, I'd never seen anything like this. It's, I think, a Romanesque. Is it cauliflower, broccoli? I don't remember, but it had this beautiful pattern. And something like this causes you to stop, to notice, to ask the question, why? Why? How did this piece of broccoli actually form and develop this beautiful pattern? Or maybe you notice the turbulence under an airplane wing, right? That's noticing beauty, and that beauty draws you in and causes you to ask why. Or maybe the tiling. This is a recent discovery from just a couple years ago of a tiling that can only a tile that can only fit together and tile the entire plane in a non-periodic way. These are called aperiodic tilings. They only fit together in a way that will never repeat um, if you continued it on forever. And we didn't know before just this past a couple years ago that such tilings existed. And in fact, and so that's a tantalizing question. Is it always possible to have an aperiodic tiling with only one tile? Um, and actually, I was captivated by tilings before this. I even tiled my front porch. This is my front porch with a tiling pattern that actually involves two different shapes. It's an aperiodic tiling. And only a few months after I did this tiling, these mathematicians discovered the single tile that tiles the plane. And I was thinking to myself, no, I just tiled the porch. And wishing that I had waited till if I'd known about the discovery.
Are you planning to change or use
No, I'm
a new
not.
tile in a new place?
It was too much work. It was too much work. I did that tiling by hand myself, and so I
Okay.
invested a lot of effort there. I'm not going to redo it.
Maybe it could be a project with your son in a few years
Yeah,
later.
yeah, or I'll tile something else maybe.
Yeah. And
Um,
you might kind of test his perseverance as well with tiling.
yes, yes, exactly. Yeah, and we have a disposition to notice beautiful things everywhere, right? This is a picture of the rings of Saturn, which have captivated me since I was a child. And notice the beautiful patterns in the rings that can all be many of them can be explained through mathematics or mathematical ideas. And so here's another virtue that's built by a great math education: the expectation of enchantment. The expectation that if you dig deeper, you're going to see things that are weird and wonderful. So, an example from the rings of Saturn here are the discovery when we sent the first probes to Saturn, that there are actually moons that move among the rings that keep the rings in their place. They're called shepherding moons, and they discovered these moons that actually every once in a while switch orbits. And when you see something like that, it makes you wonder, wait a minute, I didn't know the laws of physics could do that. Like, that's enchantment. Another example, if you're looking at the deep sea ocean floor, you go down there, you find these weird creatures that you never knew existed, right? Like this fish with a light at the end of its nose, right?
Mhm.
That's enchantment. And so in mathematics, it can look like this. Uh, one time I was walking through the hallway, and my colleague, who had just 3D printed this Menger sponge, which is basically a cube with a bunch of cubes cut out of it. He said to me, "Hey, Francis, do you know what happens if you slice a Menger sponge diagonally?" And I was only half paying attention, and I said, "No, I have no idea." And he said, "Take a look at this." And I was
Mm,
like, "Whoa, wait a
mhm,
minute. Where did those stars come from?" And suddenly I was hooked. Suddenly I was interested. Suddenly I stopped what I was doing, and it made me want to go and study these pieces, right? So when you see something enchanting, it actually evokes awe. It compels you to study it closer, and it motivates creativity, right? Like it made me want to go home and try this at home with a cube of cheese, right? Like figure out where do the six sides of the star come come from in relation to the cube. And just a hint, I'll tell you, it has something to do with the six sides of the cube.
mhm,
But this kind of enchantment is actually what causes you to come back for more, right? So if you think about kids who are motivated, interested in mathematics, it's because they're enchanted by it. And that's what keeps them coming back for more. It's not the skills, right? It's not the skills that cause them to come back, like doing, 20 multiplication problems. That's not what's going to excite a kid, right? Now, it might be necessary to learn, but just like, when you learn to play a sport, it's not the skills that draw you to the game, it's the love of the game itself, right? It's the enchantment that is built when you see a basketball game. That's what's going to make you go home and practice your free throws. Here's another example. If you take a look, there's these puzzles that are built on mathematical ideas. And if you take a look at this triangle that's cut into lots of pieces, um, and you rearrange it, suddenly there's a square missing.
mhm.
What?
What's
What is
going on?
what is going on? It makes you want to study it closer. And in fact, you could, for instance, look at this for many days or weeks, and not be able to figure out what's going on until maybe you learn that unit in geometry on about the slopes of lines, and you look at the slopes of the blue triangle and the red triangle, and if you notice, they're not exactly the same, right? And so that's a clue as to where the missing square came from. And I'll just give you a hint. The ratios are Fibonacci ratios, and those ratios can often be very close to one another, so it can fool the eye. But that's a hint. Uh,
Mhm,
this is enchantment, right? It causes you want to look closer. A few years ago, we had a mathematical artist named Scott Kim, He's famous for doing this thing where he can pick two words from the audience, and then he thinks about it a minute, and then he draws a word that one way reads one thing, like in this example, Harvey Mudd, and the other way reads another thing when you turn it upside down. And so if you
mhm.
turn this upside down, you see a different word. Mathematics.
Yeah.
And it makes you, when you see that, you're like, whoa, how did he do that? It makes you want to study it more closely, right? That's enchantment. And so I think every great mathematical experience, every great, mathematical education, classroom experience should involve enchantment, right? Yes, we need to practice skills, but how can we think about enchanting students with the desire to see beauty and appreciate mathematical beauty? Here's an example I like to use. When I was a kid, one of my friends, my parents had a friend who is a math teacher, and he said, "Hey, Francis, I hear you like math. Can you add up the numbers from 1 to 100? Can you figure out what that is?" And of course, I had no idea. It seemed like very complicated, very hard. And he said, "Actually, there's a very simple idea here that makes it really easy to solve." And I'll just show you how you might think about it with the numbers 1 through 10. So if you think about the numbers lined up in a row, 1 through 10, and you grab the first number and the last number, those add up to 11. But if you move in from both ends and you look at 2 and 9, those also add up to 11. If you continue in that way, you get a bunch of pairs that add up to 11, and there are 5 pairs. So 5 times 11 is 55. And so similarly, you can do that with the numbers 1 through 100, can't you? 1 through 100, everybody can do this with me. If you line them all up, you grab the first and the last, that's 101, that they add up to 101. And if I grab every pair, those also add up to 101. And how many pairs are there with 100 numbers total?
50.
50. So 50 times 101, you can almost do in your head is 5,050. Whoa, amazing. So when I saw that as a little kid, that's one of the first experiences I remember thinking, that is cool, right? That's mathematics, right? That's the beauty of mathematics. And so this ability to change perspectives is another virtue built by great math education, that if you look at a problem in a different way, it might be easier to solve. And so, there's a whole bunch of mathematical identities that, if you look in a different way, you can begin to understand. So this fact that the sum of the cubes is just the square of the sum of the numbers is, and that's always true, is hard to understand why it's true from looking at the numbers, but it's easier to understand when you look at a figure where I've taken a cube of side length 5 and cubes of side length 4, 3, 2, and 1, and I rearrange the squares in a flat way to be the square of the sum of those numbers. Ah, okay, I now see why it's true. Okay, so my point here is that if you think about these virtues, and I've only talked about 3 of them here, but there are many more. The virtues that are built by great math education, then you realize that math is actually multidimensional, right? A great math education builds in us a certain playfulness. It builds in us concentration. It builds in us the ability to interpret, to be inventive. It builds in us the ability to look at the structure of a problem. And so notice here that the virtues there are many different kinds of virtues, and all of us are mathematical people because all of us have some of these virtues and have to grow in other ways, some of the other virtues, right? So, like I might be very good at visualization, but not very good at algebra. Are you with me? And so I we're all mathematical people, and we all have ways in which we express mathematical virtues and ways in which we have room to grow. And so if you see this, then there really isn't, it really is not the case that there are math people and then some people are not math people. No, all of us are mathematical people, and all of us have, at least in some measure, some of these virtues. And so, the question that I'm going to leave with us here, and I'll just just highlight for you how I've been thinking about it, is how should this change the way we teach mathematics? So some of you are going to be teachers, not necessarily math. All of us are going to be, involved in somebody else's life, and so in some sense, all of us are teachers of mathematics, right? We're ambassadors for how people think about math in their lives. And I'll just mention that there are studies that show that the attitudes of parents towards mathematics actually strongly affect their children's experience of mathematics. And so, if you are a parent with math anxiety, then
Mhm.
there's a strong chance that your kids will pick up that anxiety. And so, it matters for all of us to think about framing mathematics differently, not just a bunch of skills, but as virtues. And by the way, I
Doctor,
just
so
mentioned, yeah, go ahead.
I heard several times this story. I hated mathematics, and then I came across with a very nice guy, maybe at middle school or maybe at high school. I started to like math with that teacher. I mean, his attitude or her attitude really
Yes.
impacted my life, and then I started working hard for math and started to learn from the very beginning, from the scratch. So I hear lots of the stories like this when I introduce myself as a math teacher.
Yes. Yes. And many of those examples you mentioned have to, a person their perspective was changed because of the influence of another human being in their life, right? Who exemplified, I would say, virtues that
Mhm.
attracted the student to want to learn more. So I'll
Even
just
tru-
finish.
y-
Yeah,
yeah,
go ahead.
even trusting the student is kind of adding a lot, right? If even if saying that you guys can do math will add a lot to students, I guess.
Yes, yes, that's so true. I'll finish with just a few ideas of how I've rethought some of the ways that I teach mathematics that might give you some ideas if you're a teacher or a parent or have some involvement in some other person's life around mathematics. So one of the things that I've thought about is this question. If virtues are really so important, why do people get the message that skills are important?
Hmm.
Um, one of the reasons is that skills are easy to assess, but
Mhm.
virtues are not, right? Like, you can give a kid, 20 problems, arithmetic problems, and then grade that and think, "Okay, I've measured what it means for this kid to be mathematical." And many kids get the very wrong impression from these kinds of tests that somehow speed is a mathematical virtue. It actually isn't a virtue. Like, speed, yes, it's important to know your number facts, but when you get to advanced levels of mathematics, you don't really need speed as much as you need deep thinking, right? Being able to think deeply about hard problems is a virtue. Speed is only important because you just don't want to have to reach for a calculator all the time. And so I often tell my kids, like, anything a calculator can do really isn't math.
Mhm.
Math is about deep thinking, and the calculator's for convenience. And so, one of the things I started to think about is how I change what I value by signaling to students that I value different things through the assessments. I'll show you some examples in a minute. The first thing you might do is change your goals. Like, if you are a teacher, you have goals. And, my mathematics department realized several years ago that we actually had goals, but they were all very clinical. They didn't have anything in there that related to emotional engagement. And so one of our first goals now is mathematical affection. The students should appreciate the beauty, fun, and power of mathematics and be able to articulate what it is that mathematicians do. So changing your goals actually will help you rethink many of the things that you're actually doing as you're teaching mathematics. Uh, Here's another thing that I've gotten good at in terms of trying to change my students' engagement around mathematics. Many times skills-based, problems, if you're a teacher, yes, you have to test them. You want students to know how to do certain skills, but sometimes they don't even involve any real thinking. Like this problem, compute the area of a rectangle. Okay, well, they just have to multiply 2 numbers to get an answer, but they never even think about what an area is. And so I claim richer, more interesting problems like this one actually get at area. They're actually much more fun for students, right? Like, create 2 rectangles so that the first has a bigger perimeter and the second has a bigger area. That's a more interesting challenge. And you really have to wrestle with what an area means. This example is due to Ben Orlin from his book, Math with Bad Drawings. Here's another thing that I like to do is to try to introduce moments of joy in the classroom. And so I have a website. You can Google Math Fun Facts to find it, where I've collected a bunch of things that I do in the classroom, just 5-minute things that introduce students to see a more beautiful side of mathematics. I think very carefully about how I coach collaboration, how I get students to work together with each other to solve mathematical problems. And that's becoming increasingly a much more important virtue in today's age, right? Where you're working with teams of people. That's a part of the mathematical experience as well, is having the joy of working with other people. I also have a handout we've developed in our department to coach students around communicating mathematics, how you write mathematics up. And again, if you Google my name and writing math well, you'll probably find my website that has these handouts on them. I'm very careful to call out what it means, what are good practices in mathematics, right? Like learn drawing a picture or starting with simple cases, right? These are all good problem solving strategies that are virtues built by a good mathematics disposition. And then on my exams or assessments, I reward intellectual humility, right? Like here, I've asked students to, if they can't solve a problem completely, explain where your solution has gaps. And ever since I started doing that, students actually turn in much more thoughtful, well written responses rather than turning in, an answer and hoping that I won't notice that the problem has gaps. So I'm rewarding the things I say I value, right? If I value circumspection, intellectual humility, then I'm doing that here. And then I assign reflection questions that help ask my students to reflect on virtues. So, for instance, take a problem you've struggled to solve and explain how the struggle itself was valuable. And I usually ask them for a little more information like, how did this build aspects of character in you? Here's another example. What ideas are you curious about as a result of taking this class?
Mhm.
Here's another example. For any problem you can't solve, give me a strategy you might use to tackle the problem. Aha, I'm rewarding strategization, like being able to at least have a strategy, even if you can't fully solve the problem. Here's one I'll finish with this example of a question, a reflection on beauty. And you can find more of these on a website, 7 exam questions for pandemic, where I basically, I'm trying to signal to students that reflection is valuable. And I don't worry about, I usually give full credit, almost full credit to any thoughtful response.
Mhm.
But students generally come, you know, come up with, very thoughtful answers. And by doing this, they're engaging in formative assessment. So, like for instance, here, give me an idea of course you found beautiful. And here's the important part. I usually ask them to connect it to what it means to be a human being.
Mhm.
So, I was teaching this advanced course on polynomials called Galois theory, and one student said they found the idea of minimal polynomials beautiful. Okay, whatever that is, I've taught this many times. I have never found minimal polynomials beautiful. And yet my student said this. She said, "This kind of beauty is reminiscent of the idea of a soulmate who, in some sense, matches you perfectly and who you always want to be together with. Roots of the same minimal polynomial have the same nature and never occur without each other." I love this response because I've never thought of it that way. But now that my student has said this and I see the truth of her response, now when I teach the subject, I talk about the roots of polynomials being soulmates, right? And it's given me as a teacher a better language to talk about my own subject. All right. So I think there's a lot I think we can do in our teaching experiences to encourage students to be reflective around many of these virtues. I like this response. This is the last quote I have here, where a student basically said, when they find something beautiful in math, it's achieved by the satisfaction that you found some order, a way of connecting ideas that felt disconnected. And then she goes on to say, as humans, we often contemplate the meaning of life, wondering if there's any meaning, searching for some form of order in our world. And when something interesting exists, I hope it's not merely accident, but rather due to some huge plan or order that I don't fully understand. Right. So this is, you hear the human side of a student connecting the human side of themselves to mathematics, right? They're trying to search for meaning, and mathematics sometimes gives them that experience. That's what attracts students to mathematics. Okay, and so in closing, I'll just say this, that I hope you come away from this talk realizing that math is actually more than just skills, and that we need to do more as teachers, potential future parents, to build virtues through having students work on mathematics and to teach towards human flourishing. Thank you very much.
Thank you, Dr. Su. It was a very insightful, very diverse set of ideas represented in a very short period of time. For more, they need to start reading the book, I guess. Thanks for the great speech. So I
Yeah, thank you so
invite.
much for having me.
Mhm. So we hope to see you in Istanbul, maybe in Institute Socials physically as well.
Yes,
So
that would be wonderful sometime.
okay, have a nice rest of the day.
Thank you. You too.